All right, for fifth hour, we're going to finish our notes so that you can get caught up with everybody else while you're listening to Frank and his mosh pit. So, just quick review. Solving polynomial equations has to be set equal to 0 first. If the degree is greater than 2, we're going to divide out any real zeros. After we divide out real zeros, we're going to have a quadratic left over that you have to solve. And remember, solving quadratics, you factor if you can, and if you cannot factor, you have to use the quadratic formula. All right, so moving along, we have critique and explain. So we have two polynomial functions, g of x, h of x. Elijah was doing some thinking, and he has a conjecture that is basically a guess that the zeros of a polynomial function have to be positive or negative factors of its constant term. So it tells us to factor g of x completely. So g of x, we have x squared minus 7x minus 18. Now, I'm going to solve that by setting it equal to 0 to find out the zeros. We can factor, the only factors to get x squared are x and x. Factors of 18 that subtract to 7 are 9 and 2. The bigger one I want to be negative. The smaller one will be positive. And these factors will work. Really? Oh, it's a beautiful day to math. This is Mr. Stevens. How can I help you today? She is down at Miss Sharp's working on chemistry. Yes. Thank you. Love you too. Bye-bye. All right. When we have factor set equal to the 0, the zero product property says to set each factor equal to 0 and solve. All right, here we add 9 to both sides, so x would equal 9. Subtract 2 from both sides, and x will equal negative 2. So 9 and negative 2 are indeed factors of 18, positive and negative factors of the constant. So this shows to be true for Elijah. Now let's try the other one. Looking at relationships, we're going to test Elijah's conjecture by factoring h of x. That's the second polynomial function there. So we have 5x squared plus 24x plus 16 set equal to 0. And factoring this, the only thing that multiplies to give me a 5x squared would be 5x and x. Factors of 16 that are closest together are 4 and 4. Same sign, both positive. Now, the inside will give me a 4x. The outside is a 20x. 4x plus 20x is 24x, so I know that to be true. Those are the factors. Now we set that equal to 0. 5x plus 4 equal to 0, and x plus 4 equal to 0, and we solve. So subtract 4, so 5x equals negative 4. Divide by 5, so x equals negative 4/5. On the other one, we subtract 4, so x equals a negative 4. Now, are the zeros factors of the constant? In other words, if I were to multiply negative 4/5 times negative 4, would the result be 16? And we can see that that is not the case. So it's not always true that the zeros are factors of the constant. But it is true in a very specific case. So I'm going to say it up here. Note, if the leading coefficient is equal to 1, right? If my leading coefficient is equal to 1, comma, then the zeros are factors of the constant. A sub 0 is constant. If my leading coefficient is not 1, then those zeros are not necessarily factors of the constant. And that's okay. Alright, moving along. I know, if I'm moving too fast, you can always pause. That's the beauty of videos. Technology. Alright, so here it says the concept is the rational root theorem. The essential question for all of 3-6. How are the roots of a polynomial equation related to the coefficients and the degree of the... You know what we need to do here? We're introducing words that I need to be a little bit more clear of here. Rogan, can you hear me?
Yeah.
Good. Rogan, I'm going to ask you a series of questions all with the exact same answer. So looking back at the previous problem, how many zeros did we get for that first function? Good. What was the degree? Good. How many roots did we end up with? 2. Good. What was the degree? How many solutions did we get to that equation?
2.
And what was the degree?
2.
Yeah. Let's take a look at the other equation here. How many zeros did we end up with?
2.
And what was the degree?
2.
How many roots did we have?
2.
And the degree was?
2.
How many solutions did we have to that polynomial equation?
2.
And the degree was? Yeah. So notice that I'm asking it in different ways, but all with the exact same meaning, right? So what were the words that I was using interchangeably?
Like the zeros.
Yeah.
The roots.
Roots, zeros, and solutions. All the exact same thing. All of those will tell us x-intercepts and factors. To be fair, I'm recording, so you're going to get this via email later. All right. So when I say roots or zeros or solutions, all three of these words are the same meaning. Right? There's some ambiguity here. Different words with the same meaning. I guess that's anti-ambiguity. I don't know. I'm not an English major, so I don't care. All right. Looking at this guy here. The rational root theorem. So again, we're just looking at solutions to that equation. So when we set this polynomial equal to 0, if that equation has any rational roots, then each rational root will be in the form of p divided by q. So p is a factor of the constant, and q is a factor of the leading coefficient. So, I really like the way I said it in third hour, so we're going to steal their notes. That's right. So the way I like to say this, the possible rational roots are in the form a sub 0 divided by a sub n. The constant divided by the leading coefficient. You only got one song?
We got a few.
It was a kind of like same riff.
So the same riff repeatedly for 6 straight minutes?
Pretty much. Yeah.
Okay, it happened.
It was pretty fantastic.
Go Frank.
I loved it.
Not now. I'm making a video.
And his music was indeed majestic.
Yeah, he's pretty good at playing.
Yeah.
To be fair, when I'm thinking about the constant and leading coefficient, these are factors. Factors of a sub 0 and a sub n. Now, how do I keep this straight? The constant and the leading coefficient. So if I take a look at a very, very basic polynomial function, like 5x minus 4, how do I know the leading coefficient? How do I know the constant? So the way I like to think about it, if I were to solve this equation for 0, 5x minus 4 equals 0, I would add the 4, and 5x would equal 4, and then I would divide by 5. So here, x would equal 4/5. Now, where did the 4 come from? Was the 4 the constant or the leading coefficient? Yeah, 4 was the constant. 5 was the leading coefficient, right? So I like to use something simple to help me remember. If I were to set just the leading term and the constant equal to 0 and solve, I would add, subtract the constant and divide by the leading coefficient. So that's how I know that the constant's in the numerator, the leading coefficient's in the denominator. Alright, so let's try this thing out. This problem says, what are the possible rational solutions? Now they gave us a graph and we know that 4 is one of them, but I'm more interested in listing all possible combinations. So, here, we need to list all possible combinations. So, P again is the constant. What is the constant for this function? 4. Good. What are all of the factors of 4? 4, 2, and 1. Good. Now Q is our leading coefficient, and that in this instance is what number? 8. Good. So what are all of the factors of 8? 8, 4, 2, and 1. Good. Really good. Alright, so any possible positive or negative combination of these numbers of P divided by these numbers of Q. So we have a bunch of fractions that we're going to list off. So x could equal positive or negative. Now I like to start with my smallest number and work my way towards the largest number of P. So I'm looking at the factors of P. I'm going to let that be my guide. So I'm going to start with 1 and divide it by all 4 of these numbers. So what is 1 divided by 1 going to give me? 1. Just 1. Plus or minus 1 divided by 2, so 1/2. Plus or minus 1 divided by 4, so 1/4. What would be the last rational root, possible rational root, for 1 in the numerator? 1/8, plus or minus 1/8. Now I've exhausted all possibilities with 1, so I like to scratch him off the list. No longer worried about him. And now I'm going to look at 2. So, I got to go through all iterations of P divided by Q. So now 2 divided by 1 is going to give me what? 2. So plus or minus 2. 2 divided by 2 is? I already got that one listed. Good. 2 divided by 4? I already got that listed. What about 2 divided by 8? Ooh, and I already got him. So I'm done with 2. Oh, that was friendly. 4 divided by 1 gives me what? 4. 4 divided by 2? Ooh, I already got that. 4 divided by 4? 1. I already got that. And 4 divided by 8? I already got that. So these are all of the possible rational roots for that function. So how many total possibilities are there for this function to have a rational root? 12. Because it's plus or minus. Right? So positive 1, negative 1. Positive 1/2, negative 1/2. Right? So there's 2 for each one of these for a grand total of 12 possibilities. Right? Alright, sweet. Let's try that again. Let's try it twice. Looking here at A, what's the value of P going to be? 8. And all of the factors of 8 are 8. What else? 4, 2, and 1. Good. Factors of Q, we have 4, 2, and 1. Good. Sweet. So now, any combination of P divided by Q. Again, I like to start with 1. So X could equal a positive or negative 1 over 1. Oh, I don't need a fraction there, do I? 1 divided by 1 is just 1. Alright, what's next? Yep, 1 divided by 2, so we get 1/2. Good, what's next?
4.
Easy. 1 over 4, yeah, good. So plus or minus 1/4. And I've exhausted every possibility with 1. Now we move on to 2. So plus or minus 2 over 1, which is just 2. What about 2 over 2? 1, good. I already got him. And 2 divided by 4? Already got that. So we're done with 2. Moving on to 4. 4 divided by 1 is 4. 4 divided by 2?
2.
Got that. And 4 divided by 4? Already got that. Sweet. And 8. Plus or minus 8. 8 over 1 is just 8, right? What about 8 over 2?
4.
I already got him. What about 8 over 4? Yeah, and I already got him. So these are all of the possible rational roots. Now, they're not all of the actual roots, right? 1, 2, 3, 4, 5, 6, 12 possibilities. There's only 4 total solutions, right? My degree here is 4, so there's only 4 roots, or 4 zeros. So not all of these are going to be the actual zeros of that function, but these are the possible values. All right, let's try B. What's the value of P here? 45. Yeah. Okay. Sweet. 45 divided by 2, that's not good. What about 3? What do we get? 15. All right, so 45, 15.
5.
Oh, 9. Nice.
Oh.
Yeah. So 9, his friend is 5. 15's friend is 3. And 1. Am I missing any? No, I don't think so. Q, what's the value of Q here? Oh, she's friendly. All the factors of 7 are 7 and 1. Can't believe I'm going to say this as a high school teacher, but please don't pet your friends. That was fun. I enjoyed saying that. Alright, so let's list them all out. Here we go. Blaine, shout them out as we go. Plus or minus what?
1/7. Or 1.
1 over 1? Yeah, 1. Yeah, good.
And 1/7.
Plus or minus 1/7. Alright, we're done with 1. Sweet. Alright, Blaine, what's next?
3.
Yep, plus or minus 3. Good.
3 over 7.
Yep, good. Plus or minus 3 over 7. Nice, well done. Summer, give me the next one.
Me?
Yeah,
Oh
you.
gosh.
Pretty sure your name is Summer. Is it Summer Ann? Summer Sue?
5,
Summer Michelle, yeah.
maybe?
Yep, 5 over 1. Good. What else?
5 over 7.
Let's go. Good job. 5 over 7. Proud of you. Miranda, what's next?
9
Yep, 9 over 1 reduces to... Yep. What else? 9 over 7. So plus or minus 9 over 7. Alright, I'm all done with the 9s. Wyatt, what's next?
Plus or minus 15.
Let's go. What else?
Plus or minus 15%.
Yeah, good. 15 over 7. Good job. Mia, what's next?
45.
Yeah, that's right. Plus or minus 45.
And then 45 over 7.
Yeah, good. Plus or minus 45 over 7. Yeah, they're going to be sticklers on Savvis. Whenever you have to do this in your homework, they're going to be sticklers about the plus or minus and the whole thing. So just make sure you're paying attention when you go to plug these in, okay? Now, we had 2, 4, 6, 8. Who do we appreciate? Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, what, 24 possible? How many total zeros should I get for B? 4. It only has 4 total zeros. But we had 24 possibilities, right? Now, before the invention of graphing calculators, they had to list all of these out in order from least to greatest, negatives to positives, and then they had to test all of these to find out which ones were real and which ones weren't, just to see what they can synthetically divide out of this thing. Now, we get a leg up because we live in an era that has, graphing calculators and AI and stuff. So we won't have to do all of that work, but it is necessary for you to understand the possible rational roots. Especially if you were doing this problem here, part B, and you got a real root of 6, is 6 a possible solution for this equation? No. 6 could not be a possible solution here. So I wouldn't even touch that. Does that make sense? Alright. That's all I have for you.
Can you go back to the